What is up, everybody? All right, this is our second video for 8.4 and using trig. So now we're going to use trig to solve for missing sides of triangles, right triangles. And in order to do that, you need to know at least one side of the triangle and one of the non-right angles. So if you look at my two diagrams I have here, I have angle 25 on the left, and I know the side, one leg is 18. In the diagram on the right, I know angle 20, and I know one of my legs is 15. Okay, so in order to be able to actually solve these, you need those two pieces of information. And before we get started, let's just do a quick refresh, right? So our acronym is SOHCAHTOA, because we're going to have to be making our ratios that we learned previously. And remember that O is for opposite, A is for adjacent, and H is for hypotenuse. And then obviously the S is for sine, the C is for cosine, and the T is for tangent. All right? And remember that when we were learning the ratios, it was the sine or the cosine or the tangent of the angle that you're focusing on equals the ratio of the sides. Okay? And so it's eventually going to be like sine of angle 25 equals a ratio of some side over another side. So let's start off with number 20, or this first one here. Now, if you haven't watched the calculator video yet, pause this and go watch the calculator video, because I do some explanation on how to do that, because I can't really show you how to use the calculator within this application. So focus angle is 25. Now, the type of side that 18 is, it's a leg, and it's touching our focus angle, so 18 is an adjacent. X is also another leg, it's not touching our focus angle, so I know X is my opposite, and I know Y is my hypotenuse because it's opposite the right angle. Now, I normally don't do this, but we're going to do it right now because it's going to help us just know which ratio to use. Now, you can solve for X or Y first. It doesn't really matter. And after you solve for one of them, technically you could use Pythagorean theorem to solve for the other side, because Pythagorean theorem, you need two of the three sides to be able to solve for the third. But I think once you get better at trig, you'll prefer to use trig, because in my mind, trig is much faster than using the Pythagorean theorem. All right? So again, our focus angle is 25. Now, 18 is an adjacent, so that means that I could use cosine or tangent, because in both of those, notice that I have an A. The A is referring to the adjacent. So for this problem, we probably would not use sine. All right? So let's go ahead and solve for X first. So I know X is an opposite. I know that 18 is an adjacent. So that means that we would use tangent, because tangent ratio uses the opposite and adjacent lengths based on the focus angle. So I would put tangent of my focus angle, 25, equals the opposite length, which is X, over my adjacent length, which is 18. Now, we're not using a calculator yet, okay? You're not going to use the calculator until you get the variable all by itself. So now we have tangent 25 equals X over 18. So we're not even going to enter this amount in our calculator. We're just going to solve this as if tangent 25 was just 25. Like, don't even worry about the tangent. So if you had 25 equals X over 18, algebraically, what would you do? You got to get the 18 out of the denominator, right? So I would multiply both sides by 18. We're going to do the same thing here. So I multiply the right and the left by 18. The 18 on the right goes away. So on the left, I have 18 times the tangent of 25 equals X. And now is when we would use our calculator. Okay, so based on watching the video that you hopefully watched before this, you enter in your calculator 18 times, you press the tangent button, make sure that you're in degrees. To figure out if you're in degrees, you have to go into the mode, because if you're in radians, it's not going to work. So 18 times the tangent of 25. Now, normally, a lot of people will do parentheses, tangent, 25. Some of your calculators might put the parenthesis for you. Okay, it's not really going to matter unless you're putting a number after the 25. So if I do 18 times tangent 25, I'm not going to have any errors. But if you do tangent 25 times 18, if you don't use a parenthesis around the 25, you might get some weird answers. Okay, and then I hit enter, and then you should get 8.393537, and a really long number. We're just going to round that to x equals 8.4. Done. That's it. Okay. Now, if I wanted to solve for y, so like I said, once I know it's 8.4, I technically could use that length in 18 and do Pythagorean theorem. But remember, 8.4 is a rounded number, and it was a really long decimal number too. So we want to try to make our answers as accurate as possible. So instead of doing that, I'm going to use trig again. Okay, so I'm still going to use the 25, I'm still going to use the 18, but now I'm going to solve for y. So for this ratio, I'm using an adjacent and I'm using a hypotenuse. That is cosine. So for this one, it would be the cosine of 25 equals adjacent over hypotenuse. Okay. Now remember, we're just doing this as simple algebra. All right, but here's a trick. Anytime you have the variable in the denominator like this, the cosine or the trig function on the left and the variable in the denominator, they can just completely swap. So that becomes y equals 18 over the cosine of 25. So again, anytime you have the variable in the denominator like this, all you can do is exchange that trig angle function with your variable. So then we get y equals 18 divided by the cosine of 25. And now once our variable is by itself, now we go to our calculator. So I'm going to go 18 divided by, now I press the cos button, cosine of 25. I'm going to hit enter, and I get y equals 19.9. And then you are all done using trig to find the lengths of a right triangle. Okay? Let's move on to our next example. So I have the 15, all right? My focus angle is 20, so that 15 is an opposite leg, the y is an adjacent, and the x is my hypotenuse. Let's go ahead and solve for the hypotenuse first on this. So if I'm using opposite and I'm using hypotenuse in this case, go back to here, that would be sine, because notice how it has the O and the H. So the sine of my focus angle 20 equals opposite over hypotenuse. That variable is in the denominator again, so now we can exchange it with our sine of 20. So x equals 15 divided by the sine of 20. Once that variable is all by itself, we then can use our calculator, right? So I can just do 15 divided by, I press the sine button, enter 20 for my angle, I hit enter, I get x equals 43.9. Okay. Now let's solve for y. Okay, so again, this is a rounded number, so I'm going to stick by using the 15 and the 20. So the 15 is still an opposite, the y is the adjacent. So which trig function uses opposite and adjacent? Tangent. So the tangent of my focus angle 20 equals opposite over adjacent. Once again, our variable has ended up in our denominator, so we're going to go ahead and exchange those. So y equals 15 divided by the tangent of 20. Now I can use my calculator. 15 divided by tan button 20, that gets me 41.2. So y equals 41.2. Now guys, one thing you can do when you get all these measurements out is you can use Pythagorean theorem. So I could do 15 squared plus 41.2 squared. That gets me 266, 15 squared plus 41.2 squared. Entering in my calculator wrong. That gets 1,922.44. Then if I do 43.9 squared, it gets me 1,927. Now the reason it's different is because these are rounded answers, and as our numbers get bigger, the more when we round those little decimals at the end, it changes it. Okay? But I promise As long as you do that and your answers are kind of close, then you probably got it correct. Okay, so like let's check our answer with that previous one. 18 squared plus, what was our x? 8.4. 8.4 squared, 394.56. 19.9 squared, 396. So a couple values off, but again, that's because we're doing all this rounding, and each one is being rounded by lots. Okay? Let's do a couple more. So for this one, focus angle is 7. So now we're being given the hypotenuse, right? So our 5 is our hypotenuse, our y is our opposite, and our x is our adjacent. Let's go ahead and solve for x first. So remember our SOHCAHTOA. So if I'm using adjacent and hypotenuse, that is cosine. So the cosine of 7 degrees equals adjacent over hypotenuse, x over 5. Got to get that 5 out of there, so we're going to multiply both sides by 5. So 5 times the cosine of 7 equals x. 5 times cosine of 7 gets me 4.9. Really close. So notice, guys, that this angle is really small. So that leg is really close to the hypotenuse length, right? So x equals, it's like 4.96. So let's just go with 4.9 because we're not going to round that to 5. Or if we want to get even better, we'll say 4.96. Okay? Now let's go ahead and solve for our opposite. So opposite and hypotenuse, that is sine. So the sine of angle 7 equals opposite over hypotenuse. Multiply both sides by 5 again. So 5 times the sine of 7 equals y. In our calculator, 5 times the sine of 7, very small number, 0.61. And because this angle is not lifting very much, right, and the hypotenuse is only 5, that does make sense. So if I did 0.61 squared plus 4.96 squared, gets me 24.97. And we know that 5 squared is 25, so I would say we're kind of right on the money. All right. Feel free to rewatch this video. We're going to do lots of examples in this, lots of practice. All right. Let me know if you have any questions.